this is part one of a discussion on the moon. The first thing we notice about the moon is that it changes its appearance over the course of about a month. So starting in this particular month we have a waning gibbous moon. It's a little more than half full, and then over the course of several days, almost a week, it goes down to a crescent, then disappears completely, and then it starts to reappear again and grows until we get to a full moon, and then it starts to shrink again. But why does it appear this way? We call these different appearances the phases of the moon, but why does it happen? Well, here we have an animation that shows what's going on. So here I have the Earth, and here I have the Sun, and here I have the moon. And the moon is half illuminated because we have the half pointing towards the Sun that's illuminated, just like that side of the Earth sees daytime. The other half is in nighttime in shadow, and it is on the Earth. So at this point we can see half of it, and we can't see half of it because it's not illuminated. And so what we actually see is this, and we call this the first quarter moon. As the moon moves around, we can see more of it, and we get to a waxing gibbous. When it's opposite the Sun, we see the entire illuminated face, and then as it continues in its orbit, it gets smaller and smaller again. When the appearance of the moon is getting smaller, we call it waning. When it is getting bigger, it is called waxing. So here we go again. We can't see it, and then here we can only see a tiny sliver of it, and then here we can see half of it, and then here we can see almost all of it, and then over here we can see the full lit side, and here it's starting to shrink again. These are the phases of the moon and their names. So here you have a static version of that. Here I've got the Earth. It turns on its axis. The Sun is over here. By definition, noon is when the Sun is directly overhead. So if you're standing here on Earth, it is noon. If you're standing here, it is 6 o'clock in the morning. If you're standing here, it's midnight. If you're standing here, it's 6 o'clock in the evening. But as the Earth turns, if you're standing here, this is going to be 6 o'clock in the morning, and then as the Earth turns, you'll end up here for noon, then here for 6 o'clock, then here for midnight, and so on. Here you can see that if the moon is in this position, we can't see it. If it's in this position, it's a crescent. It's half full, first quarter at this position, waxing gibbous, full moon at this position, waning gibbous, third quarter, which is half full again, and back again. Okay, so here I have a horizon, and what we can see is that if we're standing here, this is the horizon, the Sun is on my western horizon, it's 6 o'clock, and the Sun is going to set below my western horizon. Here, and then as the Earth turns, the horizon turns around. So here we're going to consider what happens to the new moon, which we can't see, and the Sun. And so at this point, we're standing here, it's 6 o'clock in the morning, the Sun is on our eastern horizon, it's just rising, and we're looking over here. And what happens as we turn? So as the Earth turns, we've gone from this point to this point. It's now halfway between 6 and noon, so it's 9 a.m., and the Sun is halfway up the sky. As time goes on, the horizon moves around some more. We're now at noon. The Sun is at its highest point, and it is to the south. As time continues to go on, we end up at 6 o'clock. The Sun is now on our western horizon, and it's about to disappear. Now, let's consider the full moon. So here's the full moon, and now we're standing at this point over here, and it is 6 o'clock. It's 6 o'clock in the evening, 1800 hours. The moon is on our eastern horizon, the Sun is on our western horizon. The Sun is going to set, and the moon is going to rise. So here we see the moon is rising, and then at halfway between 6 and midnight, so 9 p.m., it's about halfway up the sky. Now we've got to this point, we're standing here, it is midnight, the Sun is at its highest point in the south, moon is at its highest point in the south, and then here it's now setting on our western horizon, and it is 6 o'clock in the morning. Okay, that one was easy, but let's try one of the more complicated ones. So here we have the waxing crescent. So for it to be on our eastern horizon, it's about to rise, we have to be standing here. It's over here, we have to be standing here. This is 9 o'clock in the morning. So this waxing crescent is going to rise at 9 o'clock in the morning. But then as the Earth turns, it's going to rise up, and it's going to be at its highest point in between noon and 6 p.m., so it's at 3 p.m., it's going to be its highest point. So if you look to the south when there's a crescent moon, you should be able to see it at its highest point in the south. And then it's going to set. And what time is it going to set? Well, this is 1800, this is midnight, so this is 2100 or 9 p.m. So it will set at 9 p.m. shortly after the sun has set. Now you can see that for different positions you'll get different risings and settings. So the half phase either rises at midnight or at noon and sets at midnight or noon, depending on whether it's the first quarter or the third quarter. But it means that you can tell the time by the moon and the position of it in the sky. Is it in the east or the west or the south? Just the same way you could with the sun. You know the sun rises in the east and sets in the west. Well, so does the moon, because the earth turns. And if you know the phase, you know the geometry, and you can figure out what time it is. And so here is just a summary of that. Here we've got the sun, here's the earth, there's a lit side. The moon is always lit on one side, but what we actually see depends on the geometry. So it's a crescent when it's close to the sun, at 90 degrees to the sun it's half full, and at the opposite side it is in full phase. Okay, so that's the phases of the moon, but there are some other interesting issues that relate to the phases that we should also talk about. One of them is the idea of synodic versus sidereal periods. So the sidereal period is the time it takes the moon to complete one full orbit. What I mean by that is it goes through a full circle. It is actually an ellipse, but it goes through one full orbit at 360 degrees. Whereas the synodic period is the time between two successive new moons or two full moons. And they are not the same. But to understand why, we have to think about what this looks like. And so here I've got an animation where we can see the moon is going around the earth and the earth is going around the sun. So this is the orbit of the earth, this is the orbit of the moon. Here we have, here's the earth, here's the moon, here's the sun, they're lined up, and we won't be able to see the moon because it's in new phase. And so that's the position it's in. Now, so that's new moon. As it continues on its orbit around, we can see that to get back to the same position, that is the end of a sidereal month, a sidereal period, it's gone through a full 360 degrees, but it's not back between the earth and the sun, because the earth has moved along its orbit. And because it's approximately a month, that means the earth's moved through about a twelfth of its orbit, or 30 degrees. So it's offset by about 30 degrees. And so here's the end of the sidereal month, but we're not back at the same phase, and it has to move just a little bit further in order to get back to there. So here we can see we're back to new moon, and it's had to move through this extra approximately 30 degrees. And so we have the synodic and sidereal periods. This is just a static version of this, so that you can see it without the motion. We've got a new moon here, but when it gets back to new moon here, the earth has moved, the direction to the sun is different, and so it takes 27.3 days to do one full orbit, but an extra 2.2 days to get back to the full moon. Okay, so now we're going to talk about the size of the moon. Am I? I don't think so. No.